Okay, so we're going to start off your notes here. It's going to be a little shaky. I've tried to use a couple different cameras here and it just didn't want to work. So here is your section 1 notes. It looks like this. It is your 2-window foldable. So you can separate these two. We're going to start talking about Module 15, Lesson 1. We're going to start with substances. So a substance is anything that is always made of the same material. We also call these pure substances. So again, feel free to pause the video at any point to get your notes written down. I apologize if it's shaky, but we're going to have to deal with it right now. So the first type of substance is elements. Elements are things that are made of atoms that are all the same. So for example, copper and carbon are elements that you can have off the periodic table, but keep in mind, they are all the same. It doesn't matter where you find them. It doesn't matter how you find them. Carbon is carbon, copper is copper, oxygen is oxygen, okay? There are 92 naturally occurring elements with about 20-ish other ones that are man-made. So the first 92 elements on the periodic table are all naturally occurring in some form or another. The other 20 were an accident that happened that existed for like part of a second. And unfortunately, because they are elements, we are required to report them. But we do arrange our elements on the periodic table, which means that in the next unit, we're going to actually talk about those and how they get arranged. The second substance is what we call a compound. These are where you have 2 or more elements are combined together in a fixed proportion. For example, water is H2O, but if I add another oxygen, it's peroxide. If I go back to water and I add an extra hydrogen, it's called heavy water, which is very radioactive and you don't want it. These 3 all look the same. They're clear, colorless, odorless gases that you can get mixed up for each other. I would only want to drink this one. I would not want to drink these 2. This one will do major internal damage. This one will make you glow like Homer Simpson. They look and act differently from the elements that make up the compounds. So, for example, table salt is NaCl. Na is very explosive in water and gives off light and kind of looks like a firecracker, like moving around on the top of the water. Chlorine, we've all been in pools that had too much chlorine in it, burned your eyes, burned your nose, you can definitely feel that it's there. Well, you put the 2 of them together and they make your food taste better. It's ridiculous to see that and to know that, but it is the truth. So molecules are 2 or more atoms that are bonded together. For example, we have water molecules, sugar molecules, wool molecules, cotton molecules. Just about any compound can have a molecule attached to it. So there's the first bell. So that's your substances, okay? So let's move on to mixtures. Mixtures are materials that are made of 2 or more substances that can be separated out. They are not pure substances because they do not have a set proportion. So mixtures have 2 different types. You have a heterogeneous mixture, which I think if you remember back to 7th grade, we had heterozygous and homozygous. So heterogeneous mixtures are easily identified by their individual parts. For example, pizza and soup. You can see what kind of soup it is and you can tell what kind of pizza it is just by simply looking at it. Okay? Hetero means if I took a sample, that every sample I would take would be different. Okay? The one I use here is cereal. If I'm eating Lucky Charms, I'm not guaranteed to get the same amount of each shape of marshmallow in every single bite. So that would be a heterogeneous mixture. Or for soup, you're not guaranteed to get the same amount of noodles in your chicken noodle soup in every bite that you take. That's what hetero means. So there are 2 types of heterogeneous mixtures. One of them is called a suspension. So a suspension is a heterogeneous mixture that has liquid with something that has 1 to several other solid particles in it. Typical example of this is muddy water. You put dirt in a jar, add a little bit of water to it. You end up getting muddy water. You set it on a table and it will settle out in layers. Heaviest will settle first, and then you end up with just like pure water up on top. Now, the issue came out was when we started to make our own medicines. Because they do settle out, that creates an issue with this. There were too many people that OD'd and potentially died, especially children, because people would go to the pharmacy way back when pharmacy first started, and they wouldn't shake it up. Well, they'd end up with flavor water on the top, and they would just pour off the water, leaving the medicine to settle in the bottom. This settling meant that by the time you get down there, instead of getting 3 milligrams, you're getting 20 to 25. And it caused problems for people. You had many people we believe that potentially have died because of this. Okay. So suspensions need to be shook. Cough medicine, even though you can't see the difference, you should always shake your medicine. I use it as a rule of thumb. Just do it just in case. Okay. So the second type is what we call a colloid. A colloid is the same thing as a suspension, but it doesn't settle out. So milk, fog, paint, smoke, all that kind of stuff. Now, I know you've seen paint where, the oil comes out of it, or, you have to shake it up before you use it again. Most of the time, paint without additives in it is a colloid. Milk, if you don't get it fresh out of the cow, you don't have to shake your milk every time you take a drink. That would just be weird. Okay. The easiest way to tell the difference between these two is what we call the Tyndall effect. The Tyndall effect is how a substance scatters light. So, for example, if I have a container and I'm going to take a flashlight and I'm going to shine a light into it, okay, what it does is that the Tyndall effect means that the light will come through and it will spread out. Normally, it should come straight through, like in this little small area here. The Tyndall effect causes it to spread out. The best way to show you this and explain this to you is about fog and your brights on your car. If you've ever driven in fog or even like heavy snow, you turn your brights on and it is very hard to see. It makes it 10 times more difficult to see. So it's better to turn those off and just drive with your regular lights. That's the Tyndall effect, where the light actually spreads out rather than just continuing on in one path. Okay, so that's heterogeneous. Then we go to homogeneous. So homogeneous is where you cannot see the parts. Like in Kool-Aid, you can't see the sugar and the flavor and the dye in the Kool-Aid separate from the water. So homo means the same, which means if I took a sample from the first glass to the last glass of the Kool-Aid that I make, it should not taste nor look any different, unless you're like my kids and they decide they need to double the sugar, which I don't recommend doing. So another name for homogeneous mixture is a solution. They will stay mixed no matter what you do. They do not settle out like a heterogeneous does because you can't see the difference. So these two do have specific differences, and that's what makes up your mixtures. Okay, so this is lesson 1. I'm going to stop the video and I will attach a lesson 2 video.